Welcome to this lecture. In this lecture, we are going to be discussed about queue in Java. A queue is a container of an object, which is a linear collection of the data structure that are insert and remove according to the first in and first out principle. In last lecture, we learned about the stack, which is a concept of first in and the last out. So queue is the opposite to stack. An excellent example of a queue is a line of students in the food court. New additions to the line are made to the back of the queue, while removal or serving happens in the front. In the queue, only two operations are allowed. Number one is enqueue and number two is dequeue. So a queue is a kind of abstract data types or a collection in which the entities in the collections are kept in order and the only operations on the collections are the addition of the entities to the rear terminal position, which is called enqueue, and removal of entities from the front terminal position is called dequeue. As I told you, queue is a concept of FIFO, means first in and first out. So queue provides the services in computer science, which is a transport and the operations research where various entities such as data, objects, persons, or events are stored and held to be processed later. In this context, the queue performs the function of a buffer. So there are some operations what we do on the queue. First one is enqueue. Here you can see we are just seeing watching enqueue. So enqueue means add an item into the end of the queue, which is tail. When we just add the items from the tail, which is called enqueue. Then it's front. So front return the item at the front of the queue. And you can see dequeue. So dequeue remove or delete the items from the front of the queue. Now we see overflow states. So a queue may be implemented to have a bounded capacity. If the queue is full and does not contain enough space to accept an entity to be pursued, the queue is then considered to be an overflow state. And what is queue underflow? The dequeue operations remove an items from the top of queue. A dequeue operations either retrieval previously cancelled items or return in an empty queue. But if the queue is empty, it goes into the underflow state, which means that no items are present in the queue. When no items are present in the queue, it is called underflow. And when queue is a full stage, so it's called overflow. Now we just see a simple example of the queue with arrays. Here you can see I just creating the package here, and then here I write queue array. Now here I just write integer, which is capacity, and the capacity which is equal to 2, and this is the private here. Okay, now I just write the integer for queue, and queue is array here, and then integer which is front, which is equal to 0, and then int rear, which is equal to minus 1. Now integer, which is current size, which is equal to 0. And then here I just write public and q array. So this is a constructor for our q, means here I just create a default constructor for my q. Now, and yes, now I just write q and array, which is equal to new integer, and this dot capacity. So this is a copy and yes, it's okay. Now here I just define the method to add the element at the end of the queue. So that case I just write public void and in queue. Okay, so what is the in queue here? So you can see in queue when we just add the element through our tail. So this is called in queue, and dequeue when we just delete the element from it. So it's called dequeue. So in queue, and this is the parameters for our this method, which is item. And now here I just write if is queue full. So system.out.println, and the println here is queue is full, and increase capacity, and increase capacity, and then I just go to the rear where we just add the value. So it's a plus plus here. So now I just write if rear is greater than or equal to q array dot length, and here I am just using the AND operator, which is the current size, which is not equal to q array dot length, and here I just write rear, which is equal to 0. So the initial value of the rear here is 0. Now q array and then rear, which is equal to item, and then current size increment here, means the current size plus plus. Now system dot out dot println, and the println here is adding and then item. Okay, and here I just write q array and rear, which is equal to item. So rear is a array here. So I will go to the another method to dequeue the items from our top of the queue, means to remove the element or an items from our queue. So public void dequeue, and if is queue empty, so system dot out dot print line, and the print line here is queue is under flow. Means under flow means queue is empty here. So unable to remove element from queue. And here I just go to the else statement. If queue is not empty, then font is plus plus, sorry, the front is plus plus, and then if front is greater than queue array dot length, so what will be the output? Length minus 1. And here I just write system dot out dot print line, and the print line here is removed, and then plus queue array, which is our object, and here I just write front minus 1, and this is else statement. Now here our front is empty, here means front is 0, and then else system dot out dot print line, and the print line here is removed, and then concatenation of queue array and front minus 1. Now current size minus means the decrement operator, and now here I just create the method to check whether queue is full or not. So that case I am just using boolean here, which is queue full, and then boolean, which is status of the queue, means the status of the queue is empty or not. So here the status is false. So if current size, which is equal to queue array dot length, so queue or array dot length here, and then the status, which is equal to true, and then return status. Okay, and this is true here. So this statement will check if the queue is full or not. So now after that I am just creating the method to check the queue is empty or not. Means if our queue is empty, so this will check, this method is checked by, so it's a boolean and is queue empty, and then boolean status, which is equal to false, and current size, so it will check the current size here, and then status, which is equal to true, and here I'll write return status. Now private void and increase capacity, and then in this method I just write, so I just create a new array with the double size as the current one. So an integer new capacity, and capacity which is equal to this dot q array dot length, which is multiplication of 2, means we just taking the array size double, and then integer, and integer is an array of new array which is equal to new, and integer is new capacity. Here I just write integer which is temp front, and which is equal to front. So this element will copy to the new array, means the copy from rear to front, and integer index is also copy the rear from front, so here index is -1, while true, and then here I just write new array which is concatenation of indexed, and this dot q array, so the array elements are temp front. Okay, and here I just write temp front which is equal to 0. So temp front, so I just concatenate this front here, and then I just write if conditions for temp and temp front which is equal to this dot q array dot length, and then here I just write temp front, so it's a tmp, temporary front, and which is equal to 0, and here I just write if condition, so if current size which is equal to indexed, and index is add one element with it, so break statement here, and after this break statement I just make a new array in the queue, so this dot q array which is equal to new array, which is system dot out dot print line, and the print line here is new array capacity, and then this dot q array dot length. Now I just reset all the values from the front and the rear, means all the value from the tail and the head, so this dot front and this dot rear which is equal to 0, so not rear equal to 0, it's rear equal to indexed. Okay, now we just come to the main method to define. First of all I just create an object to it, so this is the q array, and now sorry it's here public static void main and string arguments, and then q array and q which is equal to new array. So I just create an object, so I just call object for enqueue, and here I just write the item which is for, mean I just add the item which is for, then q dot enqueue, and here enqueue is empty. I just not add any item here. So after this enqueue, so I just write q dot dequeue, means I just add this for and execute this for. Now here in the enqueue means add 56, then q dot enqueue, and here I just add 2, then q dot enqueue, and I just add 60, then q dot enqueue, and I just write 24. So after this 60, I just write q dot dequeue, so I just execute one another element again, means here I just add 4, then I just dequeue this add, so it will go to the this stage, means this index, and then I just add 56, so 4 is here, then I just add 2, 4 is here, then 60, then 4 is here, then I just dequeue, so 4 come to this stage, and now we just see the 24, and then q dot enqueue which is 98. Now q dot dequeue, q dot dequeue, and q dot dequeue. So I just execute 3 index again, and then q dot enqueue, and I just add one another element which is 300, and then q dot dequeue and q dot dequeue, and execute two more elements. Now we just see the output. So here I just write change is q to empty, and then execute it. So here you can see, first of all I just add 4 in our queue, then 4 removed from this queue. You can see here 4 I just add here from the tail, and then 4 is removed. Then the 4 is removed from the queue. Then we add the two elements here, which is 56 and 2. So here you can see I just define the capacity of the 2. So the queue is full here, now increasing the capacity. Now the array size is double here, where you can see this statement like integer new capacity, which is equal to this dot array, sorry, this dot q array dot length multiplication of 2, which is 4 now. Now here you can see that I just add the 4 here first, and then 4 removed from this, then I just add 56 and 2, so our queue is full. So now it is increasing the capacity. So new array which is the size of 4. So we have 1 2 3 4, so I just add 60, 56, 24, and 98. Then I just remove 2 from here. You can see I just add here 2, means we have the 2 size of array, this one, and then for 1 2 3 4 size, so we have the total elements are 2. Then I just remove 2, and then 60. Then I just remove 24, and then I just add here the value which is 300, and then I just remove, means DQ, this 98 from this queue, and then at the last I just remove this 300 from our queue. So this is the example of the dynamic queue implementation using array. So a queue is a kind of abstract data types or the collections in which the entities in the collections are kept in order, and the only operations on the collections are additions of the entities to the rear terminal position, which is called in queue. Means here the rear is in queue and the front is DQ. Front is DQ. Now we just see the example, and we just see the double-ended queue where we can delete or insert both the side of the queue. Let's see. So this is the example of the double-ended queue in Java. You can see here we can delete from this side, means delete from front, and the delete from rear, and we can insert from the rear and insertion from the front, means here insertion or deletion from the in queue and insertion or deletion from the D queue, means tail or head. So what is the ended double-ended queue, means DQ? A double-ended queue or a DQ is an abstract data type with generalized a queue for which elements can be added to or removed from either the front or rear. DQ means DQ is differ from the queue abstract data type or first in first out data type, where elements can only be added to one end and removed from other end. This journal class has some possible subtypes, which are an input restricted DQ is one, where deletion can be made from another both the side, but insertion can be made with one end only. Means we can delete both the side, but insertion from one side only. An output restricted DQ is one where insertion can be made at both the end, but deletion can be made from one end. Means in our double-ended queue, we can insert or delete the value in both ends. So you can DQ a stack by making insertion or deletion at the same side, but you can use DQ as a queue but making in setting elements at one end or removal element and other end in our queue. Now we just see the example of this DQ in Java. So here queue and the class DQ, and here I just write private and list, and then integer which is DQ, which is equal to new and array list and integer. So integer here. Okay, so this is an object, so private list and the DQ, so I just write here DQ1. Okay, and now here. So first, it's not taking the list here, so I just import a library which is java.util and util.array list. First one, so it will take the array list here, then import java.util and its list here. Okay, and this will take this list. Okay, now I just write public and void insert front and then integer which is item. Now here I just write, so it's the insert front. Okay, now I just add element to beginning of the queue, means we just add element in the beginning of the queue. So print line, and then here I just write adding at front, and then I just concatenate item here. Okay, and here I just write dq1 dot add which is 0 and item, and then here I just write system dot out dot print line, and the print line here is dq1. Okay, and this is our dq1, or I just change with dq. So here I just write array list. Okay, so here I just not add the body, so that was making the error in the program, and then it's a dq here. Okay, now here I just write public void and remove. So remove is a font here. Now if dq dot and dq dot is empty, so system dot out dot println, and the print line here is dq is under flow, unable to remove, means you can not be removed the index or items from this dq. So return here, and then here I just write integer remove which is equal to dq dot remove, and the value of the remove here is 0. So it's dq. Okay, so this will remove an item from beginning of the queue from here. Now system dot out dot println, and the print line here is removed from front. Okay, and then plus remove means this integer, concatenate this in integer which is rem, and remove which is dq, and then we just go to the public and void remove rear. And if dq is the empty, so system.out.println, and the print line here is dq under flow unable to remove, and return. And here I just write integer, and integer here is rem, which is equal to dq dot remove. And here the item is index dot size, so size is -1 because I am just dequeuing the value from it. So it will remove the item from the beginning of the queue. So system dot output message here is, so the message is removed from front, and then plus rem, and then system dot out dot print line, and the print line here is dq. Okay, and here after that I just write public integer and peak, which is front. So this is our peak point, which will get the element from the front without removing it. So item, which is equal to dq, and dq is get, and get value is 0. Now system dot out dot print line, and the print line here is element at first, and then plus item. And now return, so return is the item here. Now public integer and peak for the rear means to add, or so here in this method I just get the element from the rear without removing it, and item, which is equal to dq dot get, and it's dq dot size, and the size here is -1. Now system dot out dot print line, and the print line here is element at rear, and plus item here, and then return, so it will give us the return value, which is item. Now we just come to the main method and define create an object and call the object for each enqueue and gq. So main and string arguments, and here I just write the name of that, so it's dq, and so create an object to my this class, so dq, which is deq, which is equal to new and dq. Now dq dot insert front, which is 34, then dq dot insert front, which is 50, and dq dot delete front. means remove dot remove front, and deq dot remove front, and then deq dot remove front. So yes, I just removed three front, and now deq dot insert front, value is 21 here, and deq dot insert front, so value is 98, and deq dot insert front, which is the value of 50, and deq dot insert front, which is the value of 43, and deq dot remove front. Now here, and here is write capital I, and did one other mistake, which is the colon here. Now I just run this code. So first of all, I just add a value in the front, means value from this one, so which is 34, then add from the front is 50, then remove from the front is 50 and 34, and then it's 34. Now our queue is empty in this stage, and then dq is under flow, means dq is empty here, mean we just come to the this stage. Now I just write adding at the front, which is 21, so adding the front here is 21, then adding at the front, which is 98, and we have the two value which are 98, 21, then I just add 50 in the front, so 98, 98, 21, and 50 here. Then I just add 43, so the queue is going to 21, 98, 50, and 43. Now I just remove 43, means I just delete this 43 from this side, so it will execute 43, then 50 comes here, 53, so 98, 50, sorry, 98 and 50, so 98 comes here, and then 98 will delete, and then at the last 21 will delete in this queue. So this is the example of dequeue, means double ended queue in Java.